Hello everybody, Lars here. It is the 18th of July. Summer's going. Summer's almost done. Bizarre. Absolutely bizarre how fast summer went. Just a blur, a blink. I did do the whole move though, and I am here now in New Brunswick, so I guess things are kind of different. You don't know it, but you're watching the third iteration of this video. I did do a whole bunch, but I finally got my Yeti microphone here. And I hope I don't mess this up. And now, boom, 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 boom. So now I'm actually doing real sound the way I want to do the sound, and then I can compress it afterwards, and it sounds better, and blah, blah, blah. I know you don't care. Because actually, it's funny, the built-in microphone on these Alienwares that Dell sells is pretty good. It's not bad sound, but it's not like the Yeti. Yeti's a good microphone. If you ever need to buy a microphone for anything, any kind of voice recording stuff, Audacity is free. Yeti's only like $100. Boom, professional audio for $100. I am not kidding. The effects, everything you can do, it's insane. But I digress, because tonight we are going to go over a little bit about object orientation and a little bit about classes. Basically, when I tell the story, when I first start Big Bad Unit 5, which isn't really that bad, just make sure you give yourself enough time to soak everything in. But when I first start, I explain OOP that it hasn't been around as long as a lot of other ways of programming. I mean, computer programming came about really in the 40s and the 50s. When it first started, you were basically writing programs directly for a certain machine, a certain architecture. General programs that were then compiled to be run on certain machines, what we call, us computer geeks call the von Neumann architecture. That didn't really come around until the 50s, and even then, people still built for regular machines. It was like the late 50s, Harvard Basic. Later in the 60s, you had Fortran and Pascal. These were high-level languages that weren't machine-specific. They could be compiled down to different languages. And we were using Fortran and Pascal, and these were imperative languages. They were structured and high-level, but they were imperative languages. We've been doing that all along with our Python. You do a little... your data is your ingredients. You follow a certain amount of steps. You make commands until you get to the end and you reach the goal state. Well, computer scientists are always tinkering around and always looking for different ways to do things. And in the late 60s and 70s, a certain way of writing programs came about where people said, what if I want to simulate things? And what if I want to create something that's kind of like an analog for a particular thing, like a bicycle, a car, a billiard ball on a billiards table, whatever. Is there a way I can do that? And in the C programming language, I mean, in the 70s, you had this feature called struct, where you could kind of create your own data type. So people were doing object-oriented things. You'll know what I'm talking about when we get into it. And if you've read the slides, you already know a little bit about what I'm talking about. But people were doing object-oriented things before it was really built into languages. I'm not going to find the book, because actually it's probably in the cave now. I took a lot of my computer books and I brought them to the cave. But a language came out in the early 80s called Squeak, which was object-oriented, where you would create a class or a blueprint, and then you would get objects built with that class. But I'm in college. It's about 1987, 1988, and a gentleman named Bjarne Stroustrup wrote what's basically an extension for the programming language C that makes it work with object orientation, and it was called C++. And that's when the majority of people started saying, oh, now that makes sense to me. We can do things with object orientation. So C++ is a superset. It completely encompasses the programming language C. So technically, if you know C++, you're supposed to know C, but they're two different ways of doing things. They have two different kinds of libraries. So people still talk about them like they're two distinct languages. But anything you can do in C, you can do in C++. Okay? C++ is just a superset of C that lets you do things with object orientation. And you're going to see things like what we're going to do in the next couple of videos, like, polymorphism and inheritance and doing things like that. All right? So what I usually do for this first video is we start talking about object orientation the way that it's implemented in Python. Okay? And as you know, if you read the slides, and I'm just going to do, I didn't really whip up a lot of stuff. We're going to start from scratch. What I usually do in this particular video is I create an object that is a checking account. Well, I create a class, which is a blueprint for an object, and then we'll get a couple of objects and play around with it. So I'm going to code it up kind of quick, and when I'm going to explain it is when I get objects and we start using all the code we did. So you'll see what I'm talking about when we do it. The first thing we're going to do is start with the keyword class, because you can see idle turns it orange. And we're going to name this checking, because we're going to just do a checking account. And then I can just give it a colon and say, hey, we're going to start a code block. Okay? So now, when we create our blueprint, what we want to do now basically is create all of the functions that we want our object to be able to perform. But because we're object orientation now, for some reason that has never been completely explained to me, we do not call our functions functions. We call them methods. So you run a method on an object and you create your methods in the class. But, newsflash, you create them just like functions because they're kind of functions. All right? So the first thing I'm going to do when I do my checking class is I'm going to create that very special function, which is the thing that gets run when you first create the object. And C++, Java, Python, that special function or method is always called the constructor. And the way we do a constructor in Python is by saying def, as we want to define it, and we always call it double underscore. You can see I did 1, 2 underscores. In Python we call them dunders. Okay, they have special meanings. You want to do dunder, init, dunder. Okay, and that is going to be the constructor for your class. I'm going to take one variable here, but first I'm going to type the word self. We are going to talk about that later. Don't worry about it for now. For now, just think of it as a placeholder. Just think of it as something that refers to itself and a placeholder. And I'm going to take an amount, because when I first start my checking account, you always have an initial balance, an initial amount of money that you open up your account with. So I will do that. Then I will hit colon and I will say print, you have opened an account with, and then I'll just say comma amount. Okay, and then I'm going to create a variable. I'm going to call it self.balance. We'll talk about that in a second. And I'm going to make it equal to amount. Okay, self is referring to this particular object, and balance is what's called an instance variable. It's a variable that's going to be only for that object that you create with this blueprint. And as I said, you're going to understand it a little better when we actually run the thing. Okay? All right. So that's really all I want to do. I want to say I open the account, and I want to have that variable balance get defined. And then I'm pretty much done. Okay? But we want to be able to give our class some functionality. So the first thing I'm going to do is, drink a little coffee. Oh, I got one of those coffee mates, the chocolate mocha nonsense. I usually don't go in for that sweet stuff, but I did try some of this chocolate, and I got it in there now. It's good. It's really good. All right. The first thing I do when I have variables in a class is I write two kinds of methods. One's called a getter, and one is called a setter. And we usually have a getter and a setter for all of our data objects. Now here we're just going to have amount, so I only need two. And what you basically do is say get, and then starting with capital, remember I talked about it before, but something called Hungarian notation is how we do variables and do different method and function names. Lowercase starts a word, and then the rest of the words are uppercase. That's called Hungarian notation when you do programming. Just so you know. I'm going to call it get balance, and I'm just going to put self in there. Remember, they're all going to have self, and you'll see what I'm talking about when we get there. And all I need to do is return the variable self.balance, and I'm done. Okay, now I'm going to do def set balance. Now we kind of don't need the setter here because we're going to have a deposit method which is going to be able to alter the amount for us. So to be honest, I don't think I'm going to do the setter, but I want you to know that usually with variables you have getters and then you have setters, and you're going to see enough examples that you'll know that. But in this particular case, we have an alternate way of setting the balance, so we're not really going to do it. What I am going to do is I'm going to write a method called deposit, and deposit It's going to have that self that's always there and amount. And then what I'm going to do is, I think, what should I do? I'm going to say self dot balance is equal to amount. Do I want to know the old balance? I'll just do it this way. Print. You have deposited, deposited amount. Print your, and I can use a single quote there because I'm an old dog and I use the double quotes. Your new balance is, and I'll say self.balance because it's been updated. Self.balance. Okay, now we're just going to do one more thing, but it's a little more complicated than the other ones. When you want to get money out of a checking account, what do? You write a check. So basically what I'm going to do is I'm going to call this check, and it's going to be our withdrawal. Okay, and here I'm going to want self, and I'm going to want to know what to withdraw, so I'm going to say amount. All right, and then I'm going to go down here. Now, let's say I have $600 in my account, and I write a check for $700. What's going to happen? The bank is going to tell me to pound salt, and that I have insufficient funds and I can't cut that check. So we kind of want to be able to handle that. We only want to be able to cut a check for an amount we have. So the first thing I'm going to do is I'm going to say if amount is greater than, because equal to, I'm okay. If I have $100, I can cut a check for $100. I'm just going to say if amount is greater than self.balance, that I am going to say print you tried to cut a check for amount, and then I will print insufficient funds with an exclamation point, and then I will print your balance is comma self dot balance. Maybe if I spell balance right, that would be better. Okay, so if the amount's not enough, if the balance isn't enough, if the amount is too much, I'm going to do all that. I'm going to say you tried to cut a check for this amount, you have insufficient funds, your balance is this. Okay, and I'm a good doobie, so I'm going to complete that. But else, what if the amount is okay? All right. Now, if it's less than or greater than, or equal to, I mean to say, I'll be okay. So I'll do the regular functionality here in the else. And the regular functionality is print you cut a check for, hey, how about starting that off right? You cut a check for amount. Print, and then I want to add it, so I want to go self.balance plus, no, minus equals, because I'm taking it away from the balance, amount, and then print your new balance is, comma, and then self.balance. All right. Knock wood. I think we're good, except for I'm sure there's got to be a typo in there somewhere. We'll find it eventually. All right. Test, why aren't you coming up to me? Thank you. All right. So, and you're going to see this when we run through. We've got a class. It's called checking, and we've got 4 methods. One's the constructor. All we do is say we opened up the account, and then we set our instance variable, and here we only have 1. Then we have a getter, so we can always get whatever our balance is. I didn't do the setter because I'm not going to be setting the amount to different things. We do that with deposit and check. So here for my deposit, and I don't really do error checking here. I know, what if you put a negative amount in there? What if you give it the word dog? Blah, blah, blah. I get it. For demonstrations purposes, we're not going to do a lot of error checking. I'm going to assume I'm giving myself a decent number. So I'm just going to add it to the balance, And then I'm going to say you have deposited that amount, and your new balance is whatever the new balance is. And you can see I'm doing my little cheat here with my plus equals. That's just like a counter. It's just like C equals C plus 1 is the same as C plus equals 1. Okay? I do it down here with the minus too. So I can do a decrement just like I can do an increment. All right? So that's deposit. Check actually checks the amount to see what it is in relation to the balance. If the amount I want to cut is greater than my balance, I can't do that. So I say insufficient funds and I make no changes. But if it's not, well then I cut the check, I alter the balance, and then I print out what the new balance is. All right? So it's the moment of truth. What I'm going to do now is I'm going to create a variable called L account, and I'm going to make it equal to checking, the checking class with a balance of 300, and then I'm going to print L account dot, this is how we call the methods. We use the variable name and then dot get balance, and that's going to tell me the balance of my checking account, which I print up there anyway. Okay? I'm going to run this and we're going to trace through it, and then we'll test our deposit and our check in a second. Let's run this. Oh, look at that. No typos for me, please. All right, let me get an area here where we can see the code and see the results. All right. I don't look at any of this because it's all comments. When Python sees class checking, almost like a function, it puts it in memory. So boom, 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 boom. It literally puts all of that in memory. Gets here, we ignore this. Literally the first line that gets regarded is this one right here. L account assigned checking 300. So I take the variable L account and I assign it the class checking with the value 300. So I come up, do I have a class checking? I do. Okay. Here in the constructor, I have self, which is pointing to the actual object itself, and we're going to talk about that a little bit later. And the amount is 300. So what do? I say you have opened an account with 300 right here. Okay? And then I create a variable self.balance and I assign it the amount. So the variable self.balance for L account now equals 300. Okay? Then I come down here, I say print L account. Do I have a variable called L account? I do. What does it hold? It holds an object that was created with the checking class. I'm calling a method called getBalance. When I go to that class, do I have a method called getBalance? I do. What does it do? It returns the value in self.balance. Well, when we ran the constructor, we set self.balance to 300. It's still 300, so we return and print a 300. Okay? Now, the point of this is this. I'm going to do it like this. I'm going to create another account called Bob account, and I'm going to say Bob has 500 bucks. He's got more money than me. So I'm going to print B account dot get balance like that. Okay? And when I run this, you can see that I have 300 bucks, but Bob has 500 bucks, and that's the point. We've written one blueprint, but then we can use it as many times as we want and have different results. The instance variable in Bob account is 500, but the instance variable balance in L account is only 300. They each have their own balance. You use the class just like you would a blueprint to build an actual object. L account points to the actual object. B account points to the actual object. Okay? So you can create as many, just like you would at a bank. How many checking accounts are there at the bank? Lots of them, right? And that's how it kind of works. Checking account behaves the same for everybody, right? It has the same functionality, the same methods, but everybody has their own. That's your own unique object. This is just basically the rules, and then you have your own object. Okay? I'm going to Zots out Bob account for a second, and we're going to go back and we're going to test our other functionality. So I'm going to go back to Lars account, and I'm going to say Lars account deposit, and I'm going to give myself 500 bucks. Wouldn't it be nice if life were like that? And then I'm going to print the balance, but I'm going to copy and paste and save myself some time. All right, let's see if this works. Woo, it does. All right, what happened here was I deposited 500. So L account is what? It's a variable that was pointing to an object that was created with the checking class. So I come up here to checking and say, do I have a method called deposit? I do. So self points to the object. amount in this case was 500. So self.balance, I added amount to the old balance, which was 300. So now self.balance is 800. I said you have deposited 500 right here, and your new balance is 800 right there. And then when I came out, I did the same thing. I just reprinted the balance, okay? And so the balance is still 800. So my deposit works, and my deposit works pretty well. So now let's try the other part. I'm going to say L account, and I'm going to say check. And I'm going to cut a check. I have 800 bucks. I'm going to try to cut a check for 900. Let's see what happens. All right, tried to cut a check for 900. Insufficient funds. Your balance is 800. That pretty much tells the tale, right? I added my 500, so now it's 800. So I said L account, check 900. L account is what? It's a variable, holds an object we created with the checking class. The checking class, does it have a method called check? I go down, it does. Self, and what was my amount? 900. If amount, 900, is greater than self.balance, which is 800, that is true. So I don't have enough to cover my check. So you tried to cut a check for 900, you can see it right down here, insufficient funds, okay? Your balance is, and then it spits my balance back at me, okay? So now, let me do this properly, and I'll do it, instead of just changing the amount, I'll leave it like this so you guys can see when I give you this code, because I'm going to give you the code. Now when I run it, I try to cut my check for 900 and it won't let me, but it does let me cut a check for 700 and says my new balance is 100. Because now I get to check and it says, hey, amount greater than self.balance? It's not, because 700 is not greater than 800. So I go to the else. It says you cut a check for 700. I decrement my balance, 800 by 700, so now it's equal to 100, and then I print my balance, which is 100. Okay? So that's kind of the gist of it. You're using your class as a blueprint, and you're just going to, have it so you can create as many different objects as you want. Here I have Lars account and I have Bob account, and you can do all the different functionality that we created. We created those methods, and now we can run them and they act the way we want. The way to call those methods, you get a variable, you instantiate the class and create an object, okay? And then once you have an object, you can just run methods on it, all right? If you think about it, that's what we've been doing with lists. And that's what we've been doing with strings. You get your string and then you say dot upper or dot lower or up. They're just methods on an object. You created a string object. You created a list object. And now you could run different methods on it. That's all it is. You were using a class. Now, you didn't know it at the time. Okay, and I can tell you now because you're Python programmers and you know what the deal is. But even in week 1, you were using classes. You just didn't know it. Remember when you did type and it came back and said class int? It's because integer's a class. Okay, string is a class. And when you create these variables, you're really creating a class with that value, all right? Do a type on one of your old variables, a floating point or an integer or something that says class int, because it's telling you what the class is, okay? There's one more thing we're going to do. And as you know, it is my fervent hope that none of this confuses you, but I've been telling you this whole time about self, okay? And if and I'm going to zotch this out for a second. 1, 2, 3. 1, 2, 3. Let's say I come down here and I just say print self. Okay? I'm guessing it's going to tell me to pound salt. And it does. It doesn't know what self is. Self is not defined. And you say to yourself, yeah, but self is up there. And you could probably print that balance. You know what? I'll tell you a dirty little secret. You can print that balance. Oh, why didn't it not? Oh, because I didn't create an object yet. Doy. Okay. I was going to say, if you created L account and then just printed L account.balance, you'd be able to print it out as a variable. That's what I'm trying to do. What if I created L account? Amount doesn't really matter. And then I just said print L account. What would I get? Because you've been using print, and you can print string literals, and you can print integers and strings and all kinds of stuff. What if you just print a class? Or not a class, but what if you print an object that was created with a certain class? What would happen if you did that? you get this kooky thing, main checking object at blah, 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 blah. It's really all Python knows about this particular thing is its memory location, where that object you created resides, okay? It doesn't really use a name. It doesn't use any of the variables or anything like that, but it knows where it resides. It knows its memory location, okay? So now, if I say print, I think this is what I tried to do, laccount.self, I get an error. It says checking object has no attribute self. It doesn't, you know, it says, what are you talking about? But I'm like, well, it's up here. I'm using it up there. But what if I did this? What if when I created the variable, I did a print statement and I did print self? Here where I'm using it, right there, what would happen? It's going to happen when I run the constructor. So it's the first thing that's going to happen. And then I print laccount. Let's see what we get. Oh, now we get something different. If you'll notice, self and laccount are the same exact memory location. They point to the same object. What self does is basically hold a pointer to itself. Okay? So I could do this. Watch this. Bob account equal to checking 500 and then print B account. Look at this. I have the L account has the same memory address, okay, as the variable printout. Bob has a different one, but it's also the same as the self. So think of self just as something that points to itself. If you're familiar with anything C or C++ or Java, think of the this keyword. It's just something that refers to itself. And the way computers refer to things is with their memory location. It says, I don't know what you call it, but it starts here. That's common in computer science, okay? So that's what you're getting. That self in there is really the memory location. It's like, yeah, we're doing this for an object. It's this object. This object is what you want to do it for, okay? And you don't really know until you've created the object, so you can't refer to it when you're in the class. When you're writing a blueprint, you don't know the name of the boat or the name of the car. Okay, and that's kind of what this situation is. It's a way to say, hey, I'm running this method, go to this thing and do it there. That's how you get your individual instances and how things work with that. Okay, it is the last thing I want to do is to confuse you guys. So actually I'm going to zot that out and I'm going to go back to the regular code and make sure it runs. When I do that, yes, okay, so now you're in good shape. Do I still do that? Oh yeah, because I leave this in here. Just as a little hint, I'm going to knock that out, but I'm going to leave it there for you guys, okay? So now when I rerun, I'm clean. Yes, I am. All right? So that is the first review video for Unit 5. I'm not going to do a bunch of announcements. I'm going to cut it close because I got a bunch of things I have to do before I hit the hay, and I got a busy day tomorrow, and I'm going to try to get you a video every day for the next 3 days. Friday I might not be able to. Maybe that one is going to have to wait till Saturday, but definitely by the weekend, because as you're going to know, the assignment for Unit 5 is a big one. It's like Unit 3. So I want to get it to you as soon as possible so you have time to work with it. All right? Some of you learned that Unit 3 was not something you should have procrastinated with. So don't do that same thing with Unit 5, please. All right? Also, don't forget this weekend is going to be the proposal for the final project. So remember that, but I'll do announcements over the weekend when I do the last video. This is the first one. The next one, we're going to talk about polymorphism and inheritance. And then the one after that is the fun one. We talk about a whole bunch of different goodies, bells and whistles, and we really get things going. And then we're going to throw everything in a library and really work things up. Okay? So I'm going to leave you with this now. Watch this, steep in it. You probably haven't even read the slides yet. I mean, I just opened the unit today. But I do want to start getting you these resources so you have time to work with it. All right? All right. I got to go because NHL Network has the 50 best hockey saves on, and I can't miss that. That doesn't watch itself. So I have to grab this chocolate coffee and go over there and watch some of that stupid show. All right? You be good. I will be in touch tomorrow night with a brand new video, hopefully, and we'll get things running. All right? Take care. I'll talk to you later. Bye.